Hello guys, welcome back to my channel. So I'm back with video on MasterCadre paper science that was held in June 2021. So we have done first 24 question, right? Now it's time to solve the 25th question, but please subscribe my channel and like all the videos. So now let's proceed to the question, and the question says a factory operates with a superheated steam at 300 degrees Celsius and discharge the waste into the environment at 20 degrees Celsius. You have to find out the theoretical efficiency of the factory. So let's do this. Efficiency is denoted by eta. Eta is equal to 1 minus a factory operates with superheated steam at 300 degrees Celsius and discharges the waste heat into the environment at 20 degrees Celsius. So it will be T external by T internal. Okay. Now 20 degrees Celsius on conversion to Kelvin gives you what? 20 plus 273, that is 293 Kelvin. And 300 degrees Celsius will be equal to 300 plus 273, that is 573. 573. Now on solving this, what we got is 0.488. This is in fraction, or you can say it is in decimal. Now we have to convert this into percentage. So for converting this into percentage, we have to multiply this factor with 100. So your answer will be 48.8%. That means it is nearly equal to 49%. So our answer is option number D. Right? Now moving to the question number 26. So let's move to the next question. Assuming initially equimolar mixture of nitrogen and hydrogen and ideal gas behavior, the equilibrium constant for the formation of ammonia according to the reaction with the standard state pressure of 1 bar is this at 400 degrees Celsius, and the equation is given to us. The total pressure required to obtain a 10% conversion of nitrogen to ammonia at 400 degrees Celsius is what? So let's do this. So I have already solved this question. So now let's have a discussion of the solution. See, the equation was N2 plus 3H2 gives you 2NH3, that is our ammonia. Now, in the first line, it is given equimolar concentration. Equimolar concentration. So initially, let us suppose the concentration or the moles of nitrogen is 1 and the mole of hydrogen is also 1. And initially, we know that at time T is equal to 0, there is no formation of product, so the product will be 0. Now, after some time T dash, suppose the time is T dash, we have to find out after 10% change. 10% is what? 0.1, right? So the reactant nitrogen is reduced by 0.1 mole. If our nitrogen is 1, then our hydrogen is 3. So that means if our nitrogen is 0.01, then the hydrogen will be 0.03. And similarly, our ammonia will be 0.02 mole. Now, after some time, or you can say when the reaction is about to complete, that is T approaches to infinity, the remaining moles, that is 0.9 mole will react, and the remaining moles of hydrogen, that is 0.7, and the formation of 0.2 moles of ammonia will take place. Now, what are the total moles at T infinity? 0.9 plus 0.7 plus 0.2 is equal to 1.8 moles, right? Now let's find out the partial pressure of nitrogen gas. It will be the number of moles of nitrogen divided by the total number of moles. So the number of moles of nitrogen is 0.9 and the total number of moles is 1.8 into total pressure. And similarly for hydrogen, we can calculate this, and similarly for ammonia, right? Mole fraction is what? Given moles by the total number of moles. So we are just substituting their values. The formula is P X is equal to mole fraction and P. This is our formula, right? Now what is the formula for Kp? So the formula for Kp will be PNH3, that is the pressure of product divided by the pressure of reactant raised to power their stoichiometric coefficient. So pressure of ammonia raised to power their stoichiometric coefficient. What is the stoichiometry over here? Over like in front of ammonia is 2. So that's why the power over here is 2. And for nitrogen, it is 1. So that's why there is no power, or you can say there is power 1. And for hydrogen, it is 3. Now the value of Kp is given to us, that is 1.6 into 10 raised to power minus 4. And P of NH3, we have already found out 0.2 divided by 1.8 and P. And similarly for Pn2 and PH2 cube. We are just substituting the values, and after solving this, what we got is P square is equal to 0.04 multiplied by 1.8 square divided by 0.9, 0.7 cube, and 1.6 into 10 raised to power minus 4. So P square is 2623.906. Now we have to find out the under root of this value. So after solving the under root, what we got is 51.2 bar. What we got is 51.2 bar. I hope the question is clear to you. Like now, the numericals are somewhat of higher level. Okay, so you need more practice for these questions. So moving back to the next question. So let's mark the answer for 26th question, that is option number A. Now for the 27th one, the 27th question, an exothermic reaction is allowed to reach equilibrium if heat energy is then removed. Which of the following statement is correct? An exothermic reaction. What are exothermic reactions? Exothermic reactions are those reactions in which heat is evolved, or you can say heat is released. Heat is evolved, or you can say it can be written as A plus B changes to product with release of heat, right? So this is our exothermic reaction. Now they say if heat is removed, then the equilibrium, this equilibrium will shift towards product side. Why? By the use of Le-Chatelier principle. That is Le-Chatelier principle. Le-Chatelier principle deals with effect of temperature, pressure, and the change of volume. Okay, I hope you have already studied about Le-Chatelier principle, and it is a very important concept of +2 as well as BSc. Very important topic. So Le-Chatelier principle always undo the effect. It always undo the effect or the change that you have made, right? So you are removing the heat. So equilibrium will shift to the opposite side where heat is increased. So where is heat? Where are you observing heat? On the product side. So that means equilibrium will shift towards the product side. Okay. I hope the question is clear. So moving to the next one, 28th question. The 28th question says, choose the correct order of molar ionic conductivities of the following ions. molar ionic conductivities of the following ions. So lithium, we know that they all are the member of the same group. So they are like lithium, sodium, potassium, and rubidium, right? So down the group, molar ionic conductivity increases. Down the group, molar ionic conductivity increases. So the correct answer is option number C. What is the correct answer? Option number C, right? Now the next question, 29th question is the molar ionic conductance at infinite dilution of lithium halide is found to be 76.8 into 10 raised to power minus 4 Simon meter square mole inverse. The molar conductance of halide ion, if the molar ionic conductance of lithium ion is this, then what is the answer for the halide ion? Let's solve this by using the Cauchy law. Again, the topic is from +2. Okay. What does Cauchy law state? The molar ionic conductivity at infinite dilution is equal to the sum of individual ions. Sum of the molar conductivity of individual ions. So that means if we are finding out for LiX, that is lithium halide, it will be equal to lithium plus X. Now the value of LiX is 76.8 into 10 raised to power minus 4, right? And the value of lithium is 42.2 into 10 raised to power minus 4. Now we have to find out the value for X. So let it be X, right? This value is in addition. When you will shift it to the other hand side, it will be there in subtraction. So on subtracting these values, what you got is 8 minus 2 is 6, 6 minus 2 is 4, and 7 minus 4 is 34. So what you got is 34.6 into 10 raised to power minus 4 Simon meter square mole inverse. That is option number D. Now moving to the next one, that is the 30th question. Decimeter cube, mole inverse, second inverse are the units for which order of the reaction? Again, the question is from chemical kinetics and the class is +2. We know that 1 decimeter cube is equal to 1 liter. 1 decimeter cube is equal to 1 liter. So liter, let's substitute the value over here. Decimeter cube, mole inverse, second inverse. So decimeter cube is equal to liter, mole inverse, second inverse. To find out the order, what you have to do is you just have to add 1 to the power of liter. So what is the power of liter over here is 1. Now order will be 1 plus 1. That is 2. Order will be 2, right? So the units, these units are for second order reaction. What about if there is only second inverse, right? If there is second inverse, what you can do is you can substitute over here liter power 0. If liter power 0, that means order will be power of liter plus 1. What is the power of liter? 0 plus 1. The order will be 1. First order reaction. But over here, for this question, for 30th question, the answer is second order reaction. The next is, which of the following is not true for Physio's option? So Physio's option, from the name itself, it is clear it is a physical process. It is a physical process. That means there must be a physical change. And in physical change, we know it very well, there is not the formation of any new substance. No new substance is formed. No new substance is formed. That means the reaction is always reversible. So the Physio's option is always reversible. Physios option is always reversible. But in the first statement itself, it is given it is irreversible. So our incorrect statement is option number A. Rest all the statements are correct because the magnitude of Physios option decreases with rising temperature. Physios option occurs only at low temperature. It is true, and heat evolved in the Physios option is low. All the three statements are correct. The only incorrect statement is first statement. So this was all about our discussion for today. So we'll meet tomorrow in the next video. And don't forget to subscribe my channel and like all the videos. Bye-bye.